Hey guys and girls, welcome to Everything Electronic. I've got a 35-inch light bar. Its main purpose was for emergency vehicles. A lot of people want to know what makes them work, what kind of LEDs are inside of them, and what makes them so darn expensive. I think the disappointment is going to be where you guys are wondering what makes them so darn expensive. The electronics that are inside of them are actually not that sophisticated and not that expensive. So let's get to tearing this thing apart and seeing what makes it tick. Okay, I've already removed the end caps on this light bar, so I'm going to go ahead and slide the housing out this way. As you'll notice underneath, the circuit board is already exposed. And it doesn't look like they have a whole lot of thermal for the LEDs. So my guess is these are not super high powered LEDs, or you'd have a pretty good size heat sink on the back for these. And I guess we'll take one of these pods off just to kind of see what kind of optics and what LEDs that they're using, but I'm going to be kind of sure that these are a cheap LED that they're using. Okay, and before you guys start laughing, I haven't gotten everything set up here for my equipment, for my good soldering iron and everything. I don't have everything here yet. So obviously you can hear my son in the living room eating some popcorn, watching some cartoons. So we're going to unsolder this. I'm just using a cheap soldering iron and see what is underneath this and see what kind of thermal, if they're using any kind of thermal transfer for this heat on these lights. I'm going to guess not. Sure, that's disconnected there. Hoping to have everything set up before too much longer with my oscilloscope and everything, so we can do a little bit more invasive stuff. Some long screws they put in this. So let's get these out of here. Looks like we got two more. Oh, back this camera up just a little bit. Get this line backed up here. Sorry, this isn't the best lighting here we've used. So. Alright, so we've got a pot off now. It doesn't look like there's a whole lot of thermal to it. Let's move this light over here so we can see. Yeah, it doesn't look like there's a whole lot of thermal done here, so it doesn't transfer this thermal very well. And I'm going to guess, yeah, it's black on the other side, so they don't have it bare aluminum for it to transfer. And these lights kind of just pop out of there, so there's no weather sealing in here at all, so it doesn't look like they are set up for outdoors or indoors. It looks like it's specifically meant to be inside of the vehicle. And the LEDs do not look like they are of a high output. See if we can zoom in a little bit and give you a closer view of that LED there. Now it looks like there's only these are some cheap resistors that they put on there. So let me desolder the board for the microprocessor, and we'll kind of get a closer look at that and see what components they've got on this, because I'm not really impressed on the board for the light and for the optics. The optics look pretty cheap as well. They don't look look like a high quality optic. So let's unsolder this board and see what components we've got to deal with that runs this. Okay, before I unsoldered this, I wanted you guys to take a look at this. The brown wire here, if you look at the trace, that goes straight to the positive wire that is going to the module. So I think it's kind of funny that they put the brown wire as a positive, and it looks like your blue wire is going to be the negative, and your yellow and teal, that looks like a tealish color, like a greenish color, is going to be for your trigger to change up your flash pattern. So I think that was kind of funny that they used a brown and earth color as a positive on this. So what we're going to do is go ahead and see if we can't unsolder these wires here real quick. See if we can get this board unsoldered here. And what I'll do is whatever components that we find on this board, I'll go ahead and post up a data sheet of what components they are, just in case if you guys are wanting to keep track and keep along with that. These are going, and what it looks like too in these is these lights are done in pairs. So if we undo these here, you've got it looks like one terminal where you've got the positive and negative that go to one of the lights, and then off of that light it pairs up with the light right next to it. So they are wired in pairs, which I was kind of wondering how they were doing it, just because they use they only use an 8-pin microprocessor, and I know you can't use all 8 pins, and there's 8 modules on this board, or on this light bar itself. Can't use all eight pins on there, because obviously you've got to have a ground for power, you've got to have a power terminal, you've got to have a reset terminal usually on these boards. So what we'll do is we'll go ahead and move this out of the way here. We'll go ahead and flip this over and see if we can't get a kind of a close-up of what we're dealing with here as far as the board goes. Let me adjust this camera here for you guys. See if we can get in a little closer. Like I said, I don't have all my equipment here. I'm not completely set up, so the videos will get better as we go along, as well as the audio. Let's see here. So what it looks like we've got here is a couple MOSFETs that they're going to be placed in here. Let me see if I can get that name to show up for you on that MOSFET. There you go. And like I said, I'll put the data sheets, a picture of the data sheet, in with these components. But this is an N-channel MOSFET. As we move along on here, it looks like we have a transistor as well. It's going to be, it looks like an NPN transistor that we have on here. Let me see if I can get a name on there. Let's see if it'll focus in on that. I seriously doubt it will. But we have got an NPN transistor, and this is going to be a S8050. So it looks like we've got each an NPN transistor for each channel that is on here. So it looks like we've got 4, and this one's got hot snot all over it. I don't know why they hot glued all of this on here. But you've got a MOSFET here, here, and here, and then some. It looks like you got a pair of resistors for each pair of lights that are going out. And then you've got a, let's see what else we got here. We got a 78L05 in here. What that looks like, that's going to end up being, if I'm not mistaken, is going to be a positive voltage regulator. It's going to be a 3-terminal, probably 0.1 amp. Usually they make these at a maximum output current of 100 milliamps, and they range and vary from 5 volts, 6 volts, 8 volts, 12 volts, and 15 volts. So more than likely, this is probably going to be a 5 volt just to power this this microprocessor, and the microprocessor is probably going to be what's controlling your flash patterns on it, and keeping memory of which flash pattern you have it on and leaving it set as that. It's not labeled on here, which is not surprising because it's probably a Chinese part. It's not labeled on here, but what I'm going to guess is it's possibly an AT-Tiny microprocessor that they're going to be using on this. Obviously, you got to have your looks like a 25 volt 10 microfarad capacitor on there. And correct me if I'm wrong on that. I believe that's 10 microfarad. So the boards they're actually pretty cheap to make. This is all one-sided board, so it's not double-sided. So you can see all of the patterning on there. What's funny is this pin isn't even soldered onto the board. They have a pin there that's not even soldered, if you can see that. But the boards are not that complicated. They're fairly simple in their design, and that's what's so disappointing, is you pay so much for these light bars, and it all comes down to some basic electronics and programming. I think programming is the biggest portion that you have to do on these boards. And like I said, it's a single-sided board. You can see all the traces on here, and they don't have to do double-sided on this, so it's not that sophisticated of a board. So it's upsetting. It's almost like you're paying a whole lot of money for something that you can possibly build at home on your own, that a pretty intro level person with some basic skills and an Arduino can build that. And we'll actually do a project on that. We'll set up an Arduino and we'll build it. There's actually a good chance that it's something that I can probably get my daughter to help me out with. That would be pretty easy to do. So we'll see if we can't come up with a couple segments on the weekends for projects with me and my daughter. She's 5, just to show you how easy it is nowadays to program these little microprocessors and get these things to do specific things and everything. But we also have some other stuff to tear down on a few episodes later. We'll tear down some other lights. We'll tear down some more expensive lights. We've got some other brands that you guys are, I'm sure, pretty familiar with and are pretty expensive, and we'll tear those down, and you'll actually get to see the inner workings of those lights. But thank you guys for joining in. If you guys like what you've seen so far, definitely make sure you click the like button, subscribe to the channel. I'd love to have you guys on here and see many more videos that I make. And if you guys got any other suggestions on some videos and some other things you want to see torn apart, just definitely shoot me a comment down below, and we'll see if we can't make that happen. And like I said, I appreciate you guys checking us out as our first video, and hope to make many more. Hope to have the lab set up a little bit better, so we've got a little bit better audio and camera, and we can probe this with an oscilloscope and everything like that. So definitely keep us in mind and subscribe to us and watch as we grow, and we'll do a lot more exciting things on the way. So we'll talk to you guys later. Thank you.